Okay, Hector. I'm reloaded. Yo, my bad. Hey, yo. Hey, Kung Lao wristbands looking like a hitman, but a nigga tryna hit a lit man. Took her to the bathroom, through the zip man, left her leg shaking like the crib dance. Who that at the front door? Think that's a crib man. Pay that man and told him no tip man. Pack it out, pack, got my eyes low, it man. Now I'm on go like the rent man. Hey, go, 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 go. Where's the blow? Where's the go, 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 go? Where's the go, 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 go? Where's the Ricky Bobby, shaking bait, fast lane. Okay, hey, dip on that like a 10-piece. Shake it, bake, told that catch me. Shoot from the hip, I'm a hippie. Suck on my like a sippy. Watch all that when your lips speak. That's why your fucking sickly. She said that my spiffy. And that I hustle like Nipsey.
Like 30 minutes. I think we tried to.
Is there anything in there?
No. I think there may be parts more.
Alright.
About that. Yeah, no. Because
Is that a hole? In our demo, we will be collecting hydrogen gas from water through electrolysis and burning the highly flammable hydrogen gas to create a small explosion. The materials we used in our demo include a burette, a lab volt power source, alligator clips, 50 milliliters of 3 molar sulfuric acid, a 250 milliliter beaker, and copper or iron electrodes. On to lab safety. We have to make sure that our hands don't corrode, so we wore blue examination gloves, and to not go blind, we wore goggles. We wore closed-toed shoes, so if someone dropped a glass, a shard won't chop our toes off. In our lab,
safety is number one priority.
Our lab procedure includes a couple different steps. First, we mixed 50 milliliters of sulfuric acid with 50 milliliters of water. Use a ring stand to hold the burette at a certain height at which the opening is still submerged in the water, but the opening is not all the way at the bottom of the beaker and there's a little space. Obtain 2 pencils and sharpen both ends of them so that graphite is clearly showing on each end. Next, you should get a pair of alligator clips. They should have one red alligator clip and one black alligator clip, each with a cord. Next, you want to find a 50 milliliter burette and fill it completely with your acid water solution. And by completely, I mean all the way to the top. You don't want any air in your burette. You want to take that inverter burette and submerge it in your water acid solution, which should be in a beaker. Make sure that you keep your finger on the opening of the burette until the entire opening is submerged in the water acid solution. You're going to want to attach one alligator clip to each pencil. It doesn't matter which end, but make sure the metal of the alligator clip contacts the graphite. Finally, you want to attach the other free end of each alligator clip into the appropriate terminals of a power source. Plug in your power source, and when you put the pencils in the water, you should see gas forming. There will be one pencil which has a lot more gas forming than the other. Try and put that pencil under the burette, because that's the one that is creating your hydrogen gas. In our reaction, we used an electrolytic cell. An electrolytic cell is slightly different than a galvanic cell. For one, it only has a single chamber, where a galvanic cell has 2. An electrolytic cell actually has a negative E cell, which means that the reaction is non-spontaneous. This means that the cell requires a battery or some kind of power source to drive the reaction forward. An electrolytic cell still has an anode and a cathode, just like a galvanic cell. The only difference is that they're both in one single chamber. If you remember from the electrochem unit, we used the acronyms REDCat and ANOX to describe what happens at both the cathode and the anode. REDCat represents that at the cathode, a reduction reaction is taking place. And now regarding the anode, we remember the acronym ANOX, which states that in the anode, an oxidation reaction is taking place. Now that we've gone over some basics, let's look at our specific reaction. In our experiment specifically, the hydrogen was the reaction that was occurring at the cathode. The specific half reaction of the hydrogen was 2H2O plus 2E minus yields hydrogen gas plus 2OH minus. This means that the reactants at the cathode are receiving electrons. You may notice that OH is a product, which means that this reaction does actually create a basic solution. In our specific experiment, it's the oxygen that is being produced at the anode. The half reaction for this is 2H2O yields oxygen gas plus 4H plus 4 electrons. This means that the reactants at that anode are losing electrons. You may notice that in the oxygen half reaction, H plus is a product. This means that at the anode, an acidic solution will be formed. That's interesting because at the cathode, a basic solution was formed. So therefore, there seems to be an inverse effect at each the anode and the cathode when it comes to the formation of an acid or a base.